Question 2. Sketch the graph of f of t equals sine of t over the domain negative 2 pi is less than equal to t is less than equal to 0. Again, so a couple of things here that might look confusing, but they're not different at all to the last question. We'll start with this notation. Remember, that just means that t is between negative 2 pi and 0. So exactly the same as the last question where it was negative 2 pi less than x less than 0. Same thing here. So it just means we're going to be graphing between negative 2 pi and 0 on the x-axis. Now, it's not x this time, it's t. And so what's that going to change about how we approach this question? Absolutely nothing. It's just using a different letter. So yeah, for a better explanation, what's the point of doing that? Well, if I have a function and it's based on time instead, and so this one is what? ft sine t. I'll write it down. So you could say something like, it might be in like a real life situation where our we have something that rotates every second, for example. And so we can base that, we can figure out where it is or how high it is, because we're using sine. We can figure out how high it is based on how much time has passed. That's a rough explanation of why we might have a different letter there. In terms of just solving this question, it's the same as if it was x. So I'm just trying to get you used to seeing the different things and knowing what is a change that actually means I need to do something different, and what is a change that doesn't really have any difference. The only difference would be in this previous question, you could label this axis as the x-axis maybe, and then the y-axis here. And then in this question, it's t, so you would just have a t there instead of x. That's it. So let's graph it now. Let's copy down that domain, negative 2 pi less than equal to t less than equal to 0. So we're going between negative 2 pi and 0. Okay, because we're not going to have any positive numbers, we don't need this side of the x-axis again, just like with that last one. So I might even leave that last one there. Maybe I'll label it question 1. Question 2 here. But I'm going to leave it here so you can see that it's really similar. So we don't need any positive x-axis. I'll try and do this one a bit nicer. There we go. So we're not using over here, so let's just leave it like that. And then we'll go over here. It's not too big, so we'll just go to there. Okay, and we need from 0 over to negative 2 pi. Let's put negative 2 pi there. And then there's nothing, I'm going to say there's nothing unusual happening with this function, right? We're going to do some questions later where it'll be like 3 sine t plus 5 blah, blah, blah. And in those situations, we have to think more carefully. But in this one, we know that something interesting is going to happen every quarter. So we can just mark in these quarters straight away. Okay, so halfway was negative pi. Half of that, negative pi on 2. This halfway point between these two is negative 3 pi on 2. It's identical to this. Okay, negative pi on 2, negative pi, negative 3 pi on 2, negative 2 pi. It's the same. Okay, and we know that. Let's think through it first, and then we'll label the y-axis. So we're going to start, again, we're going to start at 0, because that's the most natural place to start. Sine of 0. So if we're here, remember sine is the opposite side of a triangle. And so it would be how far up and down are we going here? And the answer is 0 if it's a flat line. So sine of 0 is 0, just like it is for if we're using a positive domain. It's still 0. So it's still going to start at 0 there. But now what happens after this? So, I'll draw another unit circle just here. So we start there at 0. And then if we look at an angle like this, for example, sine is the up and down. And is it positive or negative? It's pointing down, so it's negative. And so we're going to be coming down here to whatever value we get to, which is different to cos. Cos, we start here and we're still positive after that. But, and that's the same as with cos, you go down this way as well when it's positive. But sine, if you're with positive angles, you'll be coming up. But when they're negative angles, we're going to be going down this way. So small difference there. Okay, but we can still approach it the same way as with cos. We can just look at the quadrant angles, right? So 0 is there, negative pi on 2 is here. And so we're at this point. How far up and down are we going? Well, this is purely up and down. So it's going to be the same as the hypotenuse, which is -1. And so we know we need -1. Let's put that here on our y-axis. Okay. And then we may as well put in the positive y-axis now as well, which is 1. Okay. Negative pi on 2 gives us -1. Let's put that there. Now we keep going around to pi. The sine is how much up and down we're going. So when we're at this flat line, there's no up and down. So we're back to 0. We keep going up to this one, -3 pi on 2. But here, how far up and down are we going? Lots. So it's going to be 1. Is it positive or negative? Well, we're above, like we're going up. And so it's going to be +1 this time. Whereas this one down here was -1. So +1 should be here. And then we keep going over to -2 pi, and we're back where we started. So we're not up and down at all. It's going to be the same point as this. It's going to be 0. Join the dots. Don't make it look terrible, but don't worry too much about making it look perfect. Not my best, not my worst. Completely fine. As long as we're hitting these key points here, and then we join it together in not a completely stupid way, like going with straight lines or just atrocious curves, then it's completely fine. Right, that's it for this question.